Hi class, this is section 6.3, Proving Quadrilaterals or Parallelograms. We will be able to prove that a given quadrilateral is a parallelogram today. First, let's do a quick review. Opposite angles of a parallelogram are blank. Opposite angles of parallelograms are going to be congruent. We learned all of these last lesson. Opposite sides are congruent. Consecutive angles are supplementary. You could also say that opposite sides are parallel. Diagonals blank each other. They are going to bisect each other. Remember that all of these are properties of a parallelogram. So now we're going to learn a couple of theorems that are going to help us prove that something's a parallelogram. The first one says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Next one, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So let's look at an example of each of these. Here I'm given a quadrilateral, and I can see that the diagonals are bisecting each other. I know that they are bisecting each other because each half of the diagonal is congruent. Since the diagonals are bisecting each other, I can say that this is a parallelogram. The second one, all I have marked in the picture is that one pair of opposite sides is both parallel and congruent. Anytime you see that happen, you know that that figure is a parallelogram. You don't have to know any other information. Find the variables that would make the quadrilaterals parallelograms. So here I'm given parallelogram ABDC. I tell you that AX is 2y minus 7, XD is y plus 2, CX is 3x, and XB is x plus 5. Well, I know if this is a parallelogram that these diagonals are supposed to bisect each other. That means the two halves have to be congruent. So I'm going to go through and set them equal. So I know AX has to equal XD, so I set those two values equal to get that y is equal to 9. I know that CX has to equal XB, so I set those two equal to get that x is 2.5. Over here, I know that these opposite sides have to be equal to be a parallelogram. So I set those equal to get x is equal to 2. And then the y's right here, these are consecutive angles. Remember that consecutive angles share a side, and they are supplementary. So I'm going to add these up to 180 in order to find what y is. Next two theorems. If both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. Second one, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Using what we know so far, let's decide if these pictures are parallelograms or not. Alright, the first one. I have that these two angles are marked congruent. You can see that they're marked purplish. And these two are marked congruent. Those are marked red. What type of angles are these? Well, these are alternate interior angles. If the alternate interior angles are congruent, that would mean that this top side and this bottom side are parallel. And if these alternate interior angles are congruent, then that would mean the left and the right side are parallel. Since I have two sets of parallel sides, I can use this theorem from up here to say that this is in fact a parallelogram. The next one, I know that opposite sides are congruent, so this would be a parallelogram. This one, I can see that the diagonals are bisecting each other, so this would be a parallelogram. And on this one, I have one set of opposite sides that are both congruent and parallel, so this would be a parallelogram. Alright, the last one. I don't even have to look at anything. I can tell that this is not a parallelogram because it's not a quadrilateral. This has 5 sides, which would make it a pentagon. We don't have any parallelograms that are pentagons, so that one would be a no. If you were to graph a quadrilateral, how could you determine that it is a parallelogram if all you were given was the coordinates of the vertices? So for example, if all I gave you were these points, how could you decide that this is a parallelogram? Well, one way you could see if it's a parallelogram is graph those points and see if the opposite sides are parallel. So we graph the points and I draw my figure, and now you can just count off the slope. My slope over here is going to be 4 because you go up 1, 2, 3, 4, 5, 6, 7, 8, and then over 2. 8 over 2 is 4. This slope is going to be 4 as well if you were to go count it off. The top slope is 1/4 because you go up 2 over 8. That reduces to 1/4. And the bottom slope is also 1/4. Remember, when you're counting off slope, you go up and then over to count off your slope. So the top is your y value, the bottom is your x value, and you always need to reduce. So since the opposite sides have the same slope, that means the opposite sides are parallel, so this is a parallelogram. On this page, all I've done is I've gone through and wrote down the different things that you guys learned today for saying if something's a parallelogram. The opposite sides have to be congruent for it to be a parallelogram. That's one way you can show it. Opposite angles being congruent, the diagonals bisecting each other, and one pair of opposite sides being both parallel and congruent. Here, to written it in better terms, show that both pairs of opposite sides are parallel. That's one way you can show it's a parallelogram. Show that both pairs of opposite sides are congruent, and so on and so on. So there's actually 5 ways to show that something is a parallelogram. Alright, so let's see if you met the target. You should be able to find x and y so that this quadrilateral is a parallelogram. See you in class.